Hello students, how are you? Our question now says that show that the drift speed Vd of free electrons is given as V equals I by ANE, where A is the area, N is the number density, and E is the charge of one electron. Okay, so basically this is a derivation question. It's a simple derivation. Let me start first. Let me divide here the paper. I'm sorry, it's not a straight line, but anyway. I know from before that current equals to charge by time. Okay, and I know from before that the total charge Q is actually the number of electrons multiplied by the charge of one electron, okay, here divided by time. Okay, we call this relation 1. Okay, I know from the definition of number density that it is the number of electrons in a unit volume. So here V is the volume, and since the wire has a cylindrical shape, so I can write the volume as follows. I can write instead of V I can say it's the area, the cross-sectional area of the wire multiplied by the length of the wire. Okay, so using this relation or this formula, I can find that N equals to, of course, by doing a cross multiple between this and this, okay, here and here, okay, by doing cross multiple I will have number of electrons N equals to number density multiplied by cross-sectional area of the wire multiplied by the length of the wire X. Of course, the length you can call it X or L. Now I substitute this formula in this one, in the one formula. Okay, so I will have current equals to, I have here the fraction, instead of the number of electrons it's going to be number density multiplied by the cross-sectional area, I'm sorry, okay, multiplied by the length of the wire divided by time. Okay, I know from before that here X, as we said, it's the length of the wire, so basically it's the distance that the electrons will pass. So I can say that X is a distance divided by the time. I will have speed. Of course, here I forgot to put the E. I'm sorry. Okay, so V by X by T is actually the V, the drift speed of the electrons. So I will have I equal N A V E. Of course, you can call it V or VD, the drift speed. Okay, I want now the drift speed VD. Okay, I can put this relation in a triangle, or simply to find the D I divide both sides on NAE. So I will have current divided by number density multiplied by the cross-sectional area of the wire multiplied by the charge of one electron, and this is the drift speed of the electrons passing a conductor. Okay, I hope that it's understood. If you have any question, please leave it in the comments below.